good morning, guys. And today our topic is illumination. Now, what is illumination? You can see this slide. What is illumination, guys? We all know that a body became lighted, or sometimes is a body became enlightened by some other source of light, and this phenomenon is called, and the totally phenomenon is coming under the illumination. Illumination means to enlight a object. uh, for the specific definition, we can say that illumination is the phenomenon when the material was heated up above a certain temperature. The material will start radiating the energy in the form of light, and this phenomenon is specifically called the illumination. So, illumination can be done by electrical, it can be done by any other sources. Uh, this is called mainly under this phenomenon coming under the illumination. Okay, so as an electrical engineer, and we have to know so many laws under illumination, and we have to know some design in protocols, and so that we can enlight some road, or enlight any auditorium, um, or maybe domestic area in a decent manner, and using less uh, source of energy. And this is the main motivation of the illumination study. Whenever you go for the illumination study for the master degrees is and the PhD courses, then you can see so many things, so many obstacles, and design procedure for the illumination factor. Uh, and now mm, we have to, it's actually there is generally two laws are there. One is this is the square law and cosine law, and another is Lambert law. Today I will cover, I think I can cover the inverse square law and the cosine law of illumination, and if not, I think it will be covered for this. And first we are going to the inverse square law. What is the inverse square law? Inverse square law says that the uh, illumination or illuminance, that is called E, is directly proportional to the I and inversely proportional to the distance square. This is the main thing, the inverse square law. So illuminance is the inversely proportional with the distance square. So from this picture and equation, and we'll try to show how is it coming, how it is coming. So, uh, so the statement, you should go for the statement, and the law state that the luminance E, sorry, luminance illuminations E at any point and on a plane in perpendicular to a line square, perpendicular to a line, and joining to the point, and and the source is inversely proportional to the square of the distance between the source and the place. So again, once again, we can recall this is the illuminance E, or the illumination, you can say. uh, the luminance E, luminance is defined by the E, but it is not mentioned the energy, but it is seems to the energy. That's why we are doing the E at the any point. Say that is the any point. This is the source, and this is the any point, or it may be any point. Okay, at any point on a plane in perpendicular to the line of joining. So this is the perpendicular to the line of joining. Okay, and the source is inversely proportional, to the square of distance between the source and the plane. This is the main things. Now, first phenomenon, going to the explanation, we can say, let's say here is a light is there, here is a light is there, light source. torch, maybe just remember it's torch. The light is coming from here, the area is here, but if you go for the area, the lighting area became higher, but what happens, the intensity will be decreased. So it is a totally perpendicular to the line of joining, and this is the inversely proportional. So this is, if it was D, then this is intensity high. If it is the D2, then intensity is going to lose, but the area will cover much bigger. This is the main thing. Now we have to uh, uh, explain for the explanation. How is it possible mathematically? You can remember this picture. You can remember this picture. Then I am going to the next explanation side. Say this is the E, where is E is light intensity. E is light intensity and equal to, sorry, this is the luminance, not light intensity. This is the luminance. Okay, I is the, here I is the light intensity or luminance intensity, whatever you can say. This is the luminance intensity, uh, and it is inversely proportional to the d square. E, luminance is inversely proportional to the d square. Where is d? D is the distance. If it is the source, it is the source and it is the plane, then this is the d and this is the d2. This is the d2. So these are the inversely proportional to the luminance intensity. Suppose if a source is represented with the luminance intensity I. This is the source with the luminance intensity is I, and in any direction. So in the previous section we have made a round shape. So any direction from this source to the distance are taken a radius, making the source as a center. Okay, we are taking the radius. So this is, you can say, this is the and this is the another radius. So you can see this is the R1, this is the R1, and this is the R2. Okay. Then distance and radius making the source as the center. And as per the above figure, you can see this figure and in the previous figure, and the two radius R1 and R2 are there. R1 and R2 are there, and at a distance of R1 and DE1 is the elementary surface area is taken. This is the DE1 area 1, and this is the area 2. Look, area is going to bigger. Okay. Uh, the surface area taken in this direction of the DE1 and DE2, 2 is considered as the R2 distance. Okay. So uh, DE1 and the DE2 to area within same solid angle, well, this is ohm, and with the same distance the luminance flux is the phi. With the same distance luminous in the same distance, you can see this is the flux, this is the flux density, luminous flux density, not magnetic flux density. Okay. uh, you can see there is the luminous flux and which is distributed over here it is theta. Okay, it is theta. So this is the area. Uh, Sorry, this is DE1 and this is DE2. Okay, this is the covered area. Okay, and now you can see the area DA1 at the R1 receives the same amount of luminous flux area dA2 at the and that is the dA1 and area dA2 at the R2 as the solid are the same. Okay, same flux density is covered by here and same flux density is covered by here is the same because solid are the same. Okay, and now we can say uh, I for the I intensity equal to d phi, this is d phi and divided by do, okay, as or the d1 da1 for da1 area. Okay, and same as I intensity same the I is the d phi by d ohm, same for d2 da2. Again, the solid angle for the elementary, we can say the surface is d ohm, this d ohm equal to da1 by r1 square r1 square if I equal to r1 and so this is the r1 square equal to a2 a2 equal to r2 square. Okay, this is the equation one. The illumination at the distance, the illumination, I'm going to the next slide. Next page actually. If I go for the next page, here we can say uh, the illumination at the distance R1, illumination distance at the R1 equal to E1, E1 equal to d phi by dA1. Okay, and it is coming I intensity dr d ohm, sorry, ohm divided by I dA1 dA1. Okay, this is the equation 2. Okay, then in the same way, the illuminance at the distance R2, illuminance at the distance R2 equal to E2, E2 equal to d phi 5 divided by dA2. Okay. Now it is coming I D O home divided by dA2. Okay, dA2. It is coming equation 3. Now from the equation 1 we get dA2. What is dA2? R2 square by R1 square into dA1. Okay, as d ohm in the previous equation 1 we have written d ohm equal to dA1 by R1 square equal to dA2 by R2 square. So from this equation we can get it, that is dA2. dA2, just remember the equation 1. dA2 is R2 square and divided by R1 square equal to dA1. So we can write and this portion coming here. Now the equation 3, from this equation 3 we can write E2 is the I d ohm by dA2. So putting dA2 is the, if we put the dA2, what happens? Then we know, so now if we know that E2 equal to E2 equal to I d ohm I d ohm I d ohm by a dA2 putting dA2 is the R2 square by R1 square into dA1, putting the dA2 value, we get, just uh, we get I d by R2 square by R1 square into dA1, because in equation 2 we have get this. So we can write over here R1 square divided by R2 square into I d ohm, that is I d ohm divided by dA1 dA1. So in this position you can see that R1 square by R2 square, R2 square equal to E1. Okay, because this portion is E2, so this portion is totally E1. So E2 what happens if I taking E1 here? So you can see E2 and this is E1 is taking here. E1 is, that is R1 square by R2 square. So you can see E1 is inversely proportional to the R2 and E1 is inversely proportional to the R1 square. So from this equation you can see inversely proportional to the distance square. This is the distance square or the r square. Okay, and this indicates the well-known inverse square law or relationship for this point and the source. It seems that the illumination varies inversely as the square of the illuminated point from the source. Okay, this is the main things of this square law. And now we are going to the cosine law. And guys, if you have any question, you may ask me. Otherwise, I'm going to the cosine law. The law of cosine, or you can say the cosine law of illumination. So I just use it. And now you can see the cosine law. The law states that the illuminance at a point on a plane is proportional to the cosine of the angle of light incident. Light means which light is incident. Means if you put a plane which is directly perpendicular, and if you tilt this portion by the angle of theta, then it is directly proportional to the angle of theta, cosine angle of theta. Okay, so we have to get maximum intensity. The cosine theta should be AA, at least should be very less, so that we can get this thing directly. Okay, the angle between the direction of the incident light and the normal to the plane. It means the angle cosine theta is the angle between the direction of the incident light and the normal to the plane. Okay, so we can say E means luminance is equal to I theta by d square into cos phi. Sorry, cos theta. Here is angle is theta, so we have to go for cos theta. We can write that E equal to I theta. This is intensity angle I theta divided by d square equal to sorry, not equal to, but multiplication proportional to the cos theta. Okay. Cos so E equal to I theta by d square into cos theta. This is the cosine law. Now we have to explain it. It is the point source illumination equation. Okay. Point source. Where and if the source is not a point, a huge source, then we can say there is a lots of point is there and lots of means if there is a one point, then it is the equation. But if there is a light of many points, then we can apply the many point of light. So, okay, in this way. Now, where the I theta is the luminous intensity of the source in the direction of the illuminated point. Okay, and theta is the angle between the normal to the plane, okay, containing the illuminated point and the containing the illuminated point. Look, should I do this? It is coming. This is the big, okay, where I theta is the luminous intensity, okay, of the source in the direction of the illuminated point, and theta is the angle between the normal to the plane. Theta is the angle between the normal and the plane, okay, and the line joining the source to the illuminated point, and the d is the distance of the illuminated point, okay, the line joining. Now you can see, uh, if you go for the previous picture, you can see the picture is given here. Yes, this is the main thing. This is the line joining distance, and the direction of the I is the intensity to the direction of source to the illuminated point, and the perpendicular angle of the plane is the theta. Okay. Okay. And now we are going how would I explain this? How to, we have to explain this equation. But if this is not a for point source, this cosine law of illumination can be analyzed in the term of illumination flux instead of luminous intensity. So if it is not a point, if it is point, okay, but if it's not for the point source, lots of point is there. In a source, we are assume there is lots of point source is there. So what happens? It is the flux, because flux means a branch, huge number of flux, huge number of points. So it is the flux at the point. But if it is a point, then it is a illumination. It is light intensity for point and flux for the lots of source when it is active. And now the illumination or the surface density of the light flux received by an illuminated area with respect to the light flux. The maximum illumination occurs when the element of the area received the light flux normal to its surface. Normal to its surface. Okay, it is maximum, but if you tilt, then it will not be maximum. Okay, then it is coming cosine factor. This can be happens, or we can think in the two ways. First, the tilt the elementary area angle of delta a and area, and intercept if all the light flux that it previously received, and so the illuminance falls. Or second way, if the elementary area small angle, that is the delta E, increase is, and then the illuminance. Now we can see here is coming to the flux. This is the previous plane, and this is the angle of plane. Okay, and now it is going. It is the this angle is theta. This angle and this area is del E dash equal to by cos theta. Okay, we can say for the case one, when the element is tilted by an angle of theta, when the element is tilted by the angle of theta, the amount of flux intercept del A is given by del A is given by flux uh, phi dash equal to phi of del A into del A cos theta. It is called phi cos theta. Okay. So the flux received by the del A delta area here is reduced by a factor of cos theta. Now the illuminance at the del A region is called given by E dash equal to E dash is equal to dash phi dash by del A equal to, you can say, phi by del A cos phi cos theta. So this is called E max cos phi. This is E max cos phi. This is the main thing. So if I tilt the plane, then it is coming a cos factor. So the luminance is proportional to the cos factor. And in the another case, if all the flux intercept by a larger element, and that is the delta area. Delta area. First time it was del A, and the area is became larger. That is del A dash. So del A dash is also del A by cos phi. Uh, Same way, this is del A dash equal to del A by cos theta, and it is also illumination becomes E dash equal to phi by del A dash, and that is coming phi by del A. I'm writing this here. I just use this. Right. Now it is coming also E dash equal to phi divided by del A. Okay, it is coming phi divided by del A divided by cos phi. Okay, then it is coming phi is coming del A and cos theta. Cos theta. Okay, so both the case, the approaches result is E equal we can say a cos phi factor is coming. So this is the cosine law. So we can say, again, just remember, illuminance at a point on a plane is proportional to the cosine factor. So illuminance at a point is proportional to the cosine factor. So if it is perpendicular, then flux, the intensity is high. But if it is going to theta is more and more, then its illuminance became less. Illuminance is directly proportional, but maximum intensity will covered by the factor of cos phi. Okay, if the cos factor is highest factor is 1, then okay, but it is going to reduce, then it will multiply by point a decimal factor. So this is coming the decimal factor. So intensity is quite going to the reducing factor, because cos phi is unity, then it is 1. But otherwise, if the angle is increasing from here to here, then it will go into the decimal factor. Decimal factor means the intensity going multiplied by the decimal factor means the intensity going to reduce. Okay, so this is the two factors for this units. One is inverse law and inverse square law. Another is cosine law. Okay, controlled the illumination at a point. Means illuminance at a point. So abruptly we can say that if the distance is increasing, then our illuminance will reduce by the distance square and proportional to the distance square. And if the cos angle is the plane is going to not directly perpendicular to it, it going to tilt, then also this is E1, this is E2. Okay, this is also intensity. This is luminance. Luminance will also decrease. Here is also E1. This is defined by square law. This is the E2. So this is 1 by 1. This is reducing due to the square of the distance. Square of the distance. And here is also the proportional to the cos theta. Cos theta means it is, if cos theta angle is not unity, then it is 1 by 1 reducing. Okay, this is the fundamental things of the illuminance, law of illuminance. Okay, and guys, I am going to stop here. If you have any question, you may ask me.